Okay then, let's take a look at some of these little half-life problems. These are just your simple introductory half-life problems, and we're basically going to be dividing by 2 or multiplying by 2 or using a total amount of time to figure out half-lives, etc. But first you see a sample of plutonium-244 that's radioactive. If you're starting with 500,000 atoms in the sample, how many are still going to be radioactive after 4 half-lives? So that just means I'm going to have to divide by 2 4 times. Because after the first half-life, 500,000 goes down to 250,000. Then after the second half-life, we're down to 125,000. The third will be 62,500. And then the fourth will take us down to 31,250 atoms. So that's how many would still be radioactive. Now, if someone asked you how many were stable, then you would just do the 500,000 minus the 31,250. There it is, and that would equal then, about 470,000, right? 468,750 are still stable. Okay. So now when we look at our next question here, it's talking about a sample of radium-226. There's 500 grams. If only 31.25 grams is still radioactive, how many half-lives have gone by? So this time I give you the starting amount, 500 gram sample, and we have to get down to 31.25. So basically we need to figure out how many times do we divide by 2 until we get to 31.25. And when you do that, 500 divided by 2, 250, divide by 2, 125, divide by 2, 62.5. And so you see after 4 times of dividing by 2, we get to the 31.25. So 4 half-lives have gone by. Now the next question, we're going to use a couple different times for some other questions coming up. And it says radioactive iodine has a half-life of 8.02 days. How many half-lives have gone by in 64.16 days? So we have a total time, 64.16 days, and we have a half-life time. So when we take our total time divided by the half-life time, it tells us how many half-lives have gone by. And so we're going to need that for our next couple questions. If we have some radioactive astatine-210, it has a half-life of 25 days. How many half-lives have gone by in 1,825 days? Then you simply have to take 1,825 divided by 25. Then the second question, how many years is that? You simply have to change your days to years. Okay, so we figure out there's 73 half-lives, and then when you divide 1,825 by 365 days in a year, you see that that is 5 years worth of time. Now this next question, this is one that you can possibly see coming up on your test in the near future. It gives us the half-life of radon-222 to be 3.8 days. How much of a 100-gram sample is still radioactive after 15.2 days? So we have to do both skills we've been looking at. First, I have to figure out how many half-lives is that. Then I can figure out how many times I have to divide by 2. So our total time, 15.2 days, divided by the half-life time of 3.8. There's 4 half-lives. So starting from 100, I have to divide by 2 4 times, and I get my 6.25 grams. Okay, so again, that's a good question to have in your pocket as far as, what you might see coming up on your little test. There'll also be a couple, like the previous ones we did, some little simpler ones. So number 6 is done the exact same way, so I'll let you try that one and see what you get. Now number 7, we're working backwards, if you will. The half-life of cobalt-60 is 5.2 years. If 50 grams are still radioactive after 20.8 years, how many grams were in the original sample? If you're trying to go back to the original sample, we're going to multiply by 2 instead of dividing by 2. The first part's the same though. It's 20.8 years total time. When I divide by the half-life time of 5.2, it'll tell me how many half-lives, which will tell me how many times I need to multiply by 2. So there's 4 half-lives, so 50 times 2 is 100, times 2 is 200, times 2 is 400, and one more time times 2 gets us to 800 grams. So 800 grams was what we started with. If it was like a previous question, I would say after 28.8 years, how much is still radioactive, and you would have to divide by 2 to get to 50. All right. So there'll probably be one of these coming up on your little test too. Again, when you need to find the original sample, you multiply by 2 instead of dividing by 2. So question 8 is pretty much the same way. So work that one out and see what you get. Last two, 9 and 10 here, a little bit different, so I'll work them through with you. If you have 100 grams of gold 198 and it decays down to 6.25 grams in 10.8 days, what is the half-life? All right, so this time we're actually trying to find the half-life. So first off, I know my starting amount, 100, and I know my finishing amount, 6.25. So I just have to divide by 2 and see how many times that takes to go from 100 to 6.25. That tells us how many half-lives. And then we know our total time, 10.8 days, so I can figure out the half-life from that. Okay. So again, to go from 100 to 6.25, I have to divide by 2 4 times, so it's 4 half-lives. 10.8 days is my total time. So I divide by 4, and I know that each half-life is 2.7 days. All right, our last question kind of involves radiocarbon dating. It says that our carbon-14 has a half-life of 5,730 years. An artifact is found. It has 100 grams of carbon in it. 12.5 grams are still radioactive carbon-14. So how old is this artifact? Well, again, I have my starting amount, 100 grams of carbon. 12.5 grams is my finishing amount. So how many times do I have to divide by 2? You can see it up here from our last problem. 3 gets us to 12.5. So 3 half-lives have gone by. So if 3 half-lives have gone by, then I just need to multiply by the 5,730 years. And that tells me that this artifact is 17,190 years old. I know, as old as me. Ha ha ha. All right, hope this helps, and I'll see you soon.